So, hello everyone again.
Hi guys.
As you see, we're still very sleepy, but we're ready to code and discuss. Probably today will be more of a, I don't know, discussion. We'll just play around because we're going to be using some experimental stuff. But I think that it will be very interesting, at least for my point of view. After all, this is one of the interesting things about what we started doing in commit.js, because we decided to not just do the ordinary videos where you're like people are explaining to you how to use set timeout, and even though we're going to be doing something like this today, but yeah, we decided to be developing our own, I don't know, front-end framework on top of lit HTML. And yeah, I mean, when you're doing certain stuff like this, it's always fun because you start seeing stuff that are not the way that they don't work the way that you thought they work. And yeah, you have to kind of like find workarounds and stuff like that. So it's always fun, right, guys?
Yeah, it definitely is. It's interesting to find out how and why stuff work.
Yep, I think so as well. So let's just, as usually, see where we ended last time. So I'm just quickly going to share my screen. Let me just see. Yeah.
Just a quick side note for those that don't know us, this is Iliya Idakiev and Aleksander, Kostov, and I am Harry, and we are passionate about JavaScript, the generic stuff and all, and we all work together, and the rest of the stuff we already mentioned, and that we just play around with stuff.
Yeah, if you're watching this episode for the first time, I suggest that you go and watch the previous ones. I think that they're interesting. We're just playing around with TypeScript, with decorators, with lit HTML and stuff like that. So I don't know, probably for someone it will be interesting. And we currently have developed this really ugly looking and very simple application. But you will be surprised. You will be surprised how much code we actually put into this thing, even though it might not look very big. This was actually one of the things me and Alexander and Harry were talking about when we were looking into one of our projects yesterday. When you look at it, it looks very simple and very beautiful. Everything's perfect, but underneath is just like such a complex thing. And whenever like some kind of, let's say a user decides, okay, let's change something, and we're like, this will cost so much time.
Yeah,
people don't see the underneath the project.
It looks like just a simple change, but in reality,
yeah, it's just very complex stuff. So what we did last time, we actually did some code splitting and lazy loading. What we did is this, the test2 component, it's actually being lazy loaded whenever we click here. And in the previous episode, we created this, let me just put my do not disturb. In the previous episode, we actually created this single page ruler. And as you see, it's working pretty okay. And the idea for today is to be examining this new API that is coming to the browsers. It's called RequestIdleCallback. And it was actually used before with, I mean, they were testing with it, the React framework, because they wanted to optimize their framework. Because they're doing a lot of heavy stuff whenever they're rendering the components. And further in the episode, we're probably going to be discussing why they're doing it, what they're doing, what they decided to do next, and stuff like that. So hopefully, if there are any of you who are writing React, it's going to be interesting for you. So yeah, let's see our code. I'm going to move here. So I should probably not go like into the code what we did last time. If you're interested, you can check it out. But yeah, this is what we have written. We have a few decorators, a few directives, and yeah, our components look like this. We have these templates that we're creating and binding stuff, and yeah. So what is the idea? Let's actually go here and put request idle callback to see what request idle callback is actually. As you see, like the first thing that pops up, it says that it's experimental technology, so it's not supported by all of the browsers yet, but hopefully in the future it will be, well, at least very soon, hopefully it will be in all major browsers. Currently, it is available in Chrome and Firefox. About the other browsers, there are some polyfills that you can use. They're actually ships, not polyfills. But you can actually find, I don't know, something that will work in the other browsers. I haven't actually, I tried one to see how it's working, but I was not very happy with the performance. And this is kind of tricky to actually create, like to simulate a request idle callback. But anyways, what it is, it pretty much schedules a callback for whenever the browser is idle. So if the browser is not doing anything, maybe like, let's say, the user is just reading something, or he just stopped typing something, this is when this callback will actually get fired. And the idea is that whenever, like the most important thing whenever you're developing an application is the user to have a smooth experience. And this is, you don't want to actually interrupt, for example, whenever he's typing or whenever he's scrolling, because it produces the so-called jank. You know, your page is very, it seems very broken. And the ideas of the request idle callback is just to get the callback whenever the user has done typing and to do certain operations. And usually, if you read and watch other videos, these operations are going to say that these operations should be not very, how should I say, with not high priority. For example, you can do analytics, send data to the Google Analytics or something and stuff like that, but you can do it, you can use it for other stuff as well, as we're going to be actually doing today. And before this request idle callback was, as I said, used by React. And what they have like as a problem is that they have this huge tree of components, and not only components. Inside the components, you also have different type of elements. So all the elements that are created by the JSX, pretty much they create in the new React, they create the so-called fiber. And these fibers need to be checked whenever they're rendering the applications to see if this fiber has changed and if it should be re-rendered. And this is one of the things that I really don't. I shouldn't say I don't like about React, but React seems a little bit slower when compared to other frameworks, just because they have to check, even if you have static HTML, some things that will never change, they still have to check it, just because this is how their framework works. And one of the things that I like about lit HTML is just because whenever you use the template literal, the tag functions and the template literals, were they called like that? I think so. Yeah. You can actually know which parts are static and which parts are dynamic, just because the dynamic parts are going to be wrapped in this dollar bracket thing. And all the other stuff will actually never change. And yeah, it looks like lit HTML is more performant just because it knows where the dynamic parts are. But as you see, as we will see today, there are certain issues with that we will have with lit HTML that we'll have to resolve, just because I played around a little bit yesterday with the demo that we're going to be doing today. and I was not very happy with the results actually we're going to be achieving. But maybe that's not bad, because maybe we will have to, I don't know, fork, for example, lit HTML and just rework how it works, and that sounds really fun to me. I don't know about you, but yeah, I like just experimenting with stuff and reading.
Taking that into libraries is something really, it could be something really rewarding. I
Yes.
used to be afraid of that. I was like, no, you can't do that. But it's really helpful. It's really helpful to do it sometimes, from time to time.
So as we said, yes, Harry?
And I think the greatest benefit of like looking into the deep in source libraries, because these types of codes are something like pushed from thousands of people, and even if you just read it without like using it, you can learn a lot of things, because it's actually something that is like from the cumulative mind of a lot of people, and it's so polished that it's just like poetry, you know. But yeah.
Exactly. So in the previous episodes, I actually said that we're going to be reading source code and viewing stuff. So hopefully it's going to be helpful for the people who are watching the stream. And I really wish in the future, whenever we're doing some stuff like this, to have more communication via the comments. And maybe, I don't know, it's going to be interesting to be discussing why they did certain stuff like that. Okay, so let's quickly view at what I'm talking about. So I open here. I'm not sure how visible it is. Let me just turn this off so it's more visible. So there are a few error issues, I mean not error, a few issues that I open here. So they might be interesting for you. For example, here there's an issue describing the fiber principles very closely. And there are a few questions here that are asked and answered as well. So I'm not going to read through all of them, but pretty much if you're interested in how React Fiber works and why are we going to be proceeding with developing this work loop as we're going to be doing today, probably these are going to be questions that will help you answer. Anyways, I talked about fibers. I said why, I mean, they exist and they have to be updated. But one other thing that I forgot to say is that after they are being calculated, what the React people want to do is pretty much have the rendering, or let's say the reconciliation, in two steps. So the first step is actually generating this whole tree, but this whole tree needs to be generated asynchronously, because if you have a really big application, this might jank the user experience, meaning that the browser might freeze while they're doing the reconciliation algorithm. So what they want to do is develop the so-called async rendering. And the async rendering is this thing that they're using, for example, like the request idle callback, let's say, even though they're not using it anymore. They're using it so that they can split the work into chunks. So each individual fiber will be a small chunk and it will be calculated. And whenever like the user, let's say it's idle, they're going to be doing the calculation. And if the user, for example, starts typing something, they're going to pause, or the browser will actually pause the request idle callback, and it will just say, okay, we don't have time now to continue working on the re-rendering. So after like there's more time, I mean, the best case is that they will want to continue from where they left and just continue the re-rendering. But this is something that they're still trying to figure out how to do. This is with the React concurrent mode. So yeah, this is something that we will want to be doing today. And if you go into the React source code, I'm not sure which window is I'm going to be opening. I have a few open windows here. I'm just wanting to see if we're going to see it somewhere here. No, it's not here. The work loop, where is it? Okay, there it is. So here, as I said, they have this work loop. This is a function, and it actually gets like code at a certain point. It discovers if there are any tasks to be done. So this means any fibers, and it does work. It does work on these fibers, and then it continues. If it has more time, it just continues work. If it doesn't have time, then it yields and gives the browser the ability to process other operations like input and scrolling, rendering, and stuff like that. So this is something that we'll actually be doing very in like a different way, because currently React, they have a scheduler that they're working on. This is actually the scheduler package. If I'm not sure if you can see. How did I zoom yesterday? Yep, there it is, the scheduler. So the scheduler package is going to be open source at a certain point, but they're still trying to figure out how to do things, because with every different browser, things work differently. So they want to be able to find a stable solution before, I mean, of course, releasing it to the public. And in the previous episode, I actually showed a few other threads. For example, this is the cooperative scheduling for background tasks. This is where the request idle callback is actually described, and the request animation frame and all the asynchronous APIs. And here you can actually see diagrams of how the request idle callback will work. For example, the idle period, the idle callbacks are going to be called and stuff like that in the different frames. And yeah, this is pretty interesting. So this is what we will actually be doing today. And here, as you see, we have like do work. Like this is going to be a function doing our work. We'll pretty much develop something similar to this. So guys, have you checked out the request idle callback, or you didn't have time?
I'm just taking a quick look in it.
Okay. So
Just briefly, yeah.
Okay, what do you think about it? Does it look cool to you, or you don't like
Definitely does. It's a solution for, like how you mentioned, for very specific tasks without burdening the browser, and it gives us also control by allowing us to have certain timeouts, so that, because one of the first things that you noted was on the page of the request idle callback. The first thing that was said was that it's an experimental decorator. But the second thing is that depending on the current processes, the thing that you're wanting to execute in the given callback could take a lot of time to execute. But you can pass certain deadlines, so that, for instance, if it hasn't been executed in a given time, you can forcibly execute it in the next period.
Yeah, usually like the second argument of the request timeout is actually a timeout. So if this timeout is passed, then it is forced for the callback to be executed. So, but yeah, we'll see that this. It's pretty much. I mean, it's a very useful feature. I think that it will be very helpful. But
And I have a question. So what do you think will be the future of debugging asynchronous stuff? Because right now all the JavaScript developers are kind of used to async the micro macro tasks and stuff and know what's happening when. But can you imagine, especially for beginner developers, if they're working on a project where there's like low priority tasks, they're doing like notation somewhere across the application, at some magical point when the user is like active, they receive a bug. But if they're doing everything so everything's runs smoothly, do you get where I'm going? I mean, to be like one whole new field for hell of debugging. I think the feature is pretty powerful and cool, and it will solve a lot of problems. But I think there will be a hell lot of more issues than we expect right now.
I wouldn't say so, just because you already have like the asynchronous programming. You just there are different ways for the browsers to be processing stuff. So usually, we're currently living with, for example, the ability to be creating different tasks and also creating different events. And if people are struggling with the asynchronous the asynchronicity of JavaScript, I think that the problem is of how they're actually writing their code. I mean, you should always structure your code and write as pure function as possible, and not to be able to be depending on global and like side effects. So I think that it won't be very hard, but at the other end, if you have to be using this kind of APIs, you're probably going to be able to know what you're doing. I mean, the normal developers, they won't have to use this kind of APIs, I think. I mean, not the normal developers, just if you're developing on a higher level, for example, if you're just creating, let's say, Angular components, you're just connecting them, showing certain stuff, and you're just going to be using some kind of higher level APIs. And these high level APIs internally are going to be using this kind of stuff to orchestrate everything. So that's
Yeah,
what.
totally agree. But I'm sure that a lot of people that don't have any idea what they're doing will use it, because they'll see a top like on commit.js that this is a new cool thing, and it will be fun. I mean, like, I understand your point that if you know what you're doing, everything will be safe. I'm sure a lot of people don't understand that.
Well, I mean, this is why
It will be fun.
yeah, this is why they should sit down and learn. This is one of the things that I always, when I'm talking to people who are coming into JavaScript, or they kind of say that even they know JavaScript, I'm like, okay, can you please explain me the event loop? Can you explain me what are microtasks, what are microtasks, what is the difference when is called and whatever, like what is request animation frame, for example. And they start like, okay, well, I quite don't understand this. So this is, if you don't understand this, then you don't understand how the JavaScript engine works, which means that you might know the syntax of the language and how certain things work, but you don't understand the core. So you should totally sit down and read and understand how these engines work before building any kinds of operations, because this is where the strangeness of JavaScript disappears after you learn this thing. And I think that both of you can agree with me.
Completely.
So before starting to program and to like say that you're a developer in a certain language, you should just know the core of the language. And I mean, of course, if I start, for example, writing some language now that I don't know, I mean, it's going to be strange for me, and probably I'll be like doing a lot of bugs, but that's normal. After all, I don't know the language. So
yeah, it's a new technology. So it's really important to know what you're doing. Like I'm an example of I have written a lot of JavaScript before actually learning JavaScript, and the results were atrocious.
And after you came to our course in the Sofia University, then you discovered that it's not so hard. Actually, JavaScript is really simple. You just need to learn, as I said, the core functionality. After that, everything is very, very simple. And like, I mean, it's always very easy, for example, to shoot yourself in the foot, because you have a lot of power and you can change everything. But you should just learn not to do everything as you wish, and just to follow certain principles.
When you have enough information and you know how you can shoot yourself in the foot, when you research how stuff works, like it's harder for you to do that.
Mm-hmm. Yep, I agree. Okay, let's start coding. What should I say? Should I say work loop? Okay, let's say work loop or something like that. It's going to be a directory. And inside, I'm just going to have another file, work loop. Let's create our first work loop. So what we're going to have, let's export const work loop. So for the work loop, what are we going to be needing? We're going to need some kind of a queue where actually we're going to be pushing all of the different operations that need to be done. So let's say we're going to have a queue. So in this queue, let's say that we're going to have an empty array, and I'm going to use TypeScript just to say that here we're going to have like an array of some kind of functions that return anything for now, just because we are still not sure what we're actually going to be putting in this queue. And after this queue is processed, what we're actually going to have is like another queue that is going to be a result queue. I'm just going to say result, which is going to be an array, and here we're actually going to have like a many. This is going to be actually the results. As I was like thinking yesterday, probably here we're going to be pushing some kind of functions that are returning the lit HTML node parts. And here probably we're just going to have the individual node parts, and we're just going to be saying commit on them, because the commit is actually the phase where you're saying to lit HTML, okay, I want you to commit the changes to the DOM. So pretty much probably this is going to be our structure, but I'm still not very sure. We'll see. And one other thing that we'll need is like a Boolean variable that will actually be telling us if we are already running we're already inside a running loop or we're not, because we will have to at a certain point know that we want to start this loop. So let's call it updates, or like working, is working, let's say, which is going to be false for now. And let's create our first method that is going to say, it's going to be named push work. So inside the push work, what we're going to have is this function that is going to be passed to us, let's say work, and it's going to be a function that is going to be returning a node part. And here is where we're actually going to get like the current queue and modify it. So we're going to say this.queue equals this.queue.concat. One of the things that I always do is I never mutate stuff. So probably for some of you, this might be strange, but I don't want to use, for example, operations like push or pop, just because I always want to be creating a new instance, and this is working very well for me, because certain strange things that happen, especially when you're doing asynchronous stuff, basically disappear. But you should just keep in mind that you're doing it, because you might be counting on not creating a new instance on like a property. Anyways, so here we're going to say if this dot is working, then I just want you to return. If we have not initiated like a working process, what we're going to do is I'm going to have like another method that is going to say, it is going to be named process, for example, or process work or something like that. And I'm not, I'm intentionally putting this underscore in front just because I want to, like, if other people are using this work loop, I want to, for them to know that this is not an API that they should be playing around. I can say private maybe, but because I'm creating this object like this, I cannot just do it, so never mind. And one other thing here is that because I will be pushing work, if my application is running, I want to be able for a certain stack to be able to push all the work before calling the process work method. So what I'm going to do is actually create promise dot resolve. So by calling this promise resolve.then, what I'm doing is I'm creating the so-called macro task. The macro task is this function that is going to be called after the end of the current event loops, after the end of the current stack. So whenever what I have planned for this tick is processed, this callback is going to be called, and inside here I'm actually going to say this dot process work like this. And here before that, I just need to say processor work equals false, equals true, actually. Not process work, it should be is working. And hopefully you understand this. I teach it to all of the students just because a lot of people end up not knowing that you have macro tasks and micro tasks. So this is something that is very useful. So yeah, let's continue with our process work. Here is the place where actually we'll be using the request idle callback. So what I'm quickly going to do is actually I have copied here the the TypeScript the TypeScript types for the request idle callback, because if we do something like window.request idle callback, you're going to see that we actually don't have the type definitions. So I quickly went to I searched on the internet just before the demo, so I found them. They were in the Microsoft website on GitHub, I mean. And yeah,
Side note, GitHub is actually a Microsoft website, so yeah, you are totally right.
Yeah, that's correct. GitHub was bought by Microsoft, what, like 1 year ago. They actually created this tool that automatically transfers your GitHub repositories to the Bitbucket ones, but it totally crashed. And yeah, a lot of people just ended up using GitHub, and I'm actually pretty happy with GitHub nowadays. That it's really they're doing it more powerful. I'm not sure if you actually noticed, but currently in GitHub, if you go to a certain, for example, method, you can actually click on the method and it will automatically send you to the other file that it's somewhere inside the library where this method is defined, and this is really cool. So I think Microsoft is doing a really good job currently with GitHub. And they also integrated this tool that finds, for example, how should I say, not very good packages that you're using, and they actually send you a message, and you have the ability to actually run this tool that will actually update your dependencies and like these packages that are not very safe to use. So this is really cool feature that
they also make like direct a pull request to your repository if they dig the package, the change of the package won't break anything. So it's called dependable, by the way, but it really doesn't matter.
Yeah, it's really cool. Yeah, this is. I think it was a tool that was paid before, but they bought the company, and I don't know, something like that. But never mind. Let's continue with our process work. So inside the process work, what we're going to do is use the window.requestIdleCallback. There it is. And as you see here, we're going to actually give it a callback. The callback is going to receive a deadline. This is an object that we're actually going to be using to know if we have time to do more work or we should just not do anything. So here, usually, if you see other demos, they do it with a while loop. And inside the while loop, what they do is use this deadline object. Inside the deadline object, there are two properties. The first one is time remaining. So time remaining is a function that actually returns you how much time there is left. So if it's, for example, bigger than 0, and if deadline dot did timeout, we should probably have our check to see if we actually have something in our queue as well. This dot queue dot length larger than 0. Then here, what we're actually going to be doing is processing our work. So how are we going to process this? Sorry.
The time remaining is the time remaining until the actual frame has ended. The current frame in which this idle callback is being executed has ended or not?
I think so. Yeah. Is this your question?
Sorry?
Did I say something wrong, or you're just mentioning it?
No, I'm just asking if it is that.
The time remaining is, I think, let's see in the documentation, because I'm not very sure, but time remaining or remaining time remaining. Let's see.
Maybe just in the deadline.
It's actually a method that you call. The time remaining function can be called. Okay. Can be called to get the latest value when time remaining returns 0. You can schedule another request idle callback. Okay. So pretty much it says how much time the browser is expecting until you actually are going to be able to do work. So it's not what you were saying.
Okay,
the time remaining until idle time. This is what it is.
Yes, okay. I got confused by the charts which were shown before, because the idle callbacks were just before the end of the frame, and that confused me.
No, the idle callbacks they're there, but this is because this is the idle time. This is when nothing is happening, so that's why they were there.
Yeah. That's what got me confused. So we can come back to now.
Okay.
Thanks.
So here, what we're going to do is say work equals this.q, and we're going to get the first element, and we're actually going to call this function now. So we're going to get the part and say work something like this. And here the part, we're actually going to push it into our result. So we're going to say this result equals this.result.concat with the part. And of course, we should not forget to remove this work that we actually did from the queue. So what we're going to do is say this queue equals this queue dot slice 1. So I'm pretty much getting all the rest of the items and removing the first one that we actually did. And okay, this is one of the parts that we're going to be doing. So here, what we have to check is, for example, if this result. So if we have some results to be done, what we can do, no, this is not true. We have to actually get the queue to see if we have other stuff to do. So if we have other stuff, we won't actually be, what we have to do is pretty much call the process work again, right? So if we have other stuff, we call it again. And if we don't, what we have to do is say if this dot result length is larger than 0, this means that we actually have certain things that we have to commit. And here we're actually going to have another method that is going to say commit work. And inside the commit work, what are we going to do? We'll see, but let's just call it here, like that. And I think it's pretty much this what we wanted to do.
I have a question.
Yes.
So let's say, for example, we have a lot of work in the queue. The deadline time remaining goes like 0, and we're exiting the while loop, right? After that, we're going to the if else statement, and this queue will call again the process work, right? On the sides, I mean, I'm not very sure if we are going to commit to work if our deadline time remaining is like goes to 0 and we still have the queue. Am I right, or am I missing?
I'm not sure, Harry, because you're kind of breaking up, and I don't understand what you're asking.
All right.
Can you like repeat it again or something? Are you worried that this will never be called? This is what
I'm worried that the commit work will not be called if we have like deadline time remaining 0 and we still have stuff in the queue to process.
Yeah, but if deadline time remaining is 0, I think that the whole thing will be called in the next idle callback.
This actually is a while loop, right? So we're iterating until, for example, we have the deadline. So if we reach the 0, then what we're going to do is check if we have other stuff inside the queue, and if we have other stuff, we'll just queue another process work.
Yeah, but if we have still work in the queue, but we already have some of the results, are we supposed to push those results to the application, or we are just waiting until everything in the queue is processed? Because
the idea is to wait for everything inside the queue to be processed and then
gotcha.
all the changes. So pretty much I'm doing what the React people were doing. I want to process, for example, the whole tree of our application, even though that's probably not going to be possible. And then after I have all the changes, I want to just push them at once inside the DOM, just because I don't want, for example, to have this flickering, or how should I say, like otherwise you're going to see like certain components pop up before the other ones. But as I said, probably we will have to do it this way, just because this is how the HTML works. But the idea of this work loop is kind of to simulate what the React is doing. So we process all the work, and after all the work is done, we just commit it to the DOM. That's what we're doing. Even though this
It makes sense.
This is much more. This is much easier than, I mean, not so complex as what they are doing. It's just a very simple thing. Okay, so inside the commit work, what we have to do is pretty much iterate over the results and call the commit to each individual part, right? So let's do it. This dot results. Why is this like that? I'm not sure. Oh, okay. I forgot to put commas. Okay, results. Let's say for each and for each part, what I want to do is part dot commit. So here's where I'm actually going to be pushing the changes. And after that, what I have to do is not to forget to clear the results. So I'm going to say this. Something is happening today. I cannot write. Or this is every time. I feel like every time I start doing a demo, I stop being able to type, and I just say this, and the people were like, he cannot type at all. Okay, so is there anything else that we actually need to do here? So we're committing the parts. This means that certain things are going to be generated inside the HTML. The problem, what I see here, is that as you remember, like when we were actually creating the certain directives, for example, let's see what we were creating. Not this one. I think inside the router, yes, here. Here inside the router we have where is it though? Yeah, the outlet. This outlet is very annoying just because here what we are doing is we're using this directive. We're providing the component that we currently have inside our router, the active component. And whenever we commit the work, this directive is going to be called and it will commit itself, as you see. So this means that whenever we commit, at a certain point, this commit will be called as well, which will actually schedule more work. It means that we'll actually put more work inside the queue. And this is one of the things that I think that will stop us from doing what we want to achieve. But anyways, what I forgot here to do is pretty much just say this dot is working equals false, because we're done with the processing, right?
We've committed all of the work.
Actually, I think we should do it here.
Yeah.
Just because, as I said, when we are committing, other elements might process their own work. They might push their own work. This means that after we are done with the certain stack, we need to process the work again. And if we don't do it before we're actually committing the changes, we might end up with not visible elements. So
yeah, we might miss something.
Yeah, so I think this is fine for now. Now what we have to do is change how our components work. I mean, our component decorator. So let's go inside the decorators and let's go inside the component decorator and let's include our import. Did I export it actually? I think I did, right? Yeah. Okay, from. And I have to go to work loop, something like that, to get the work loop. And here we have to change the update function. So as you see, currently what we are doing is we are actually using a macro task as well, and we are scheduling the render of the template. But here the rendering will actually be the work that we're going to push inside our work loop. So what we are going to change here is, let's say something like work loop dot push work. And here inside the push work, we're going to give it a function that we want to be called whenever we have time, when we have the idle callback. And here we can actually do it one-liner, so I don't have to be writing anything else. The render function, the render function, it will not actually do what I want.
Yeah, it won't return the node part.
So I think that, how are we going to do this though? This means that we have to call render somewhere as well, right? Okay, the template function itself is actually going to be returning, it returns a template result. That's something that we have to change. So that means that we have to modify this function, the render. Let's quickly see what the render function is doing. So let's go inside the Git Polymer lit.html master. And here we're going to search for render. So where is the render function? Come on, function inside the library, but I thought that it's going to be easier to find it like this. So maybe let's just go here and say library. There it is, render. So render, what it is doing is, yeah, there it is. So here what it's doing is getting the container, it's getting some kind of like generating some part, and it's doing certain things, but what it's doing actually is something that we don't want it to do. As you see, it's already committing the work. So what we have to do is create our own function like this one, and that is just returning the parts. So let's create it. Inside the, where should we put it? Inside the work loop, or I'm not sure. There should be like another, let's put it inside utils.
I think utils is the best solution and the best place.
I think that for certain things we should have like a library directory or something.
Yeah, for that.
Actually,
right now, it's
okay. Maybe it will be a good idea to maybe rename this to lib or something, just because we know what it is. And here we're going to say render without commit.js. Okay, so I'm just going to copy this and
TS file.
Sorry?
I'll make it a TS file.
Okay, yeah, I forgot.
Yeah, commit.js is cool, but
we should do a commit.js that we only do videos about TypeScript, maybe. Okay, so render without commit, and let's format it.
You have a small typo in without. You forgot an H. Yeah. Sorry.
No, it's not a problem. I am forgetting stuff all over the place. My screen is very small, so I'm just wondering how to put everything, but let's do it like this. And now I have to import what I don't have already imported. So we have these things.
Parts. We need to find where the parts are. I think they're defined somewhere in the.
Yeah, this is something that we need to find where it's located.
Where they're getting the
parts. Of course, weak map, weak parts. So this is how usually you use state inside lit.html. They use the weak map, but we already discussed this. We also need this remove nodes. Where is remove nodes? It's inside DOM. So let's go inside the DOM and get. Can't I just like import it? Okay, it's perfect.
Okay.
Template factory. What is template factory? Let's go back and see template factory. So template factory. Can't we just import it as well? Let's see, templates factory. Okay, perfect. Undefined expected, but got to. So I'm going to remove this. Why do we need undefined anyways? And I think that we're pretty much done. What we have to do is just return the part like this. And what we're going to do is here inside the component, we're not going to use the render from .html. We're going to actually use our custom render without commit. And hopefully we're going to see it. Okay, everything works fine. We're rendering the template, calling with everything we need. And looks fine, right?
Yeah, I think it's time to see if everything's fine.
So yeah, let's see if actually it's going to work. Let's quickly, I'm just going to build it again to make sure that everything is built correctly. And let's go inside this thing and we actually see our application, which is very cool. But we actually see this very annoying thing that I mentioned. So here, as you see, whenever I'm clicking, what is happening is that we're actually rendering this component inside the next idle callback, and this is why we are getting this kind of, I'm not sure if you can actually see it, but it quickly hides for a second and then it pops up this thing here.
Yeah, it gets
visible.
Go back and shown in the next one.
Yeah, so this is something that it's getting kind of annoying. So I think the problem is as follows. Because we're committing the work here, what happens is that another thing gets scheduled inside the push work. So the push work is being called. We can actually see this, like we can debug it. Ooh, this big console. This is from yesterday. So we should go inside the work loop. And inside the work loop, let's put a breakpoint here and one here. So actually, I'm going to remove this one because I want to re-render. See, as you see, like currently we don't have anything rendered. Inside the commit work, we're going to start rendering, but what I want to do now is put this push work here. And also put this breakpoint there. And also I want to go inside the router component and here inside this directive. And let's see what's going to happen. We start committing the changes, and currently we have another thing being pushed. This is actually the, this is from which component? Let's say this, not maybe this. Yeah, this is the router link. The router link is pushing something that's interesting. Probably just because something changed, I'm not sure why. Then what is being pushed after that is this, again, a router link. So I guess we are going to get all the router links here.
We're rendering all the components.
But what I want to see is the HG router. Okay, so the HG router is actually pushing work, as you see, and this is because the active component is being set. So let's see why this is happening. Where is the router component? So there it is. The problem is what I discussed earlier. So this callback, the connected callback is currently doing the rendering. This means that whenever the component gets attached to the DOM, it will actually do the render and it will push the active component to the do work, and then it will get rendered to the DOM. So this is why we are seeing this blinking thing. Did you guys understand, or do you see it? Okay. So any suggestions how we can fix this, or can we at all fix this is the question. So my first thought here is, for example, to see when the constructor is being called. So what I'm going to do is say maybe I'm just going to build it like this and put a debugger inside the constructor so we can see if we can actually do something inside the constructor instead of waiting for the connected callback. So let's go inside the router component and let's put a breakpoint here inside the constructor. And I think that if I start redrawing the thing, we're going to see. So we're committing the work. And now after we committed the work, we actually ended up inside the constructor. So the idea is here, if we say these roots, we're actually going to see an empty array. This is because actually the lit HTML still has not binded the roots to the router component. This means that at a certain point after the constructor, it will bind the roots, and then we will be able to process them to find the missing component. The problem here is that even if we find it, we cannot kind of like push it inside the work loop just because we're already inside the commit stage. And this is one of the issues that I discovered yesterday, is just how lit HTML creates the elements. So it actually creates the elements not whenever it's, I mean, this is not from lit HTML actually, it's just how web components work. So the web component lifecycle is as follows. Whenever you actually create a template and put, for example, individual components inside this template tag, if you include this template inside the DOM, because it's a template, it's not visible to us. So nothing gets created. But for example, if you get the content of this template, and as I said, this template includes your web components, custom elements, if you clone it and then you actually push it to, for example, append it to the DOM or like to a child, then the constructor will be the first part that it's going to be called. And after that, the connected callback. And this is just how web components work. But what we can do is individually create those components by ourselves. So what I'm talking about is, for example, what I can do here is say custom elements, because I don't have the instance for, I don't have the class declaration here available. What I can do is say get, and for example, hg router, get the definition, get the constructor. As you see, this is my decorator here. This is what we're actually seeing, but this is our constructor for the component. So we can say, let's say var ctr equals this thing. Oops. And here, what I can do is say var router equals ct new ctr, and actually here I am available to inject stuff inside this constructor, which is very, very cool. This is something that we will use probably in the future when we're creating our own dependency injection mechanism. But this is the way that we can actually construct the router. So yeah, here it says it's already constructed, but anyways, this is because we are actually, I think, stuck inside the constructor. That's why. And whenever like we have the router now as a variable, then we can actually append it to the DOM. And this is going to be the next stage where actually the connected callback will be called. So the main problem here is of how the templates of this components are processed. And one idea is to create a function that actually creates our components instead of relying to, for example, directives and stuff like that, or just the lit HTML to create them itself. I mean, something like, where is it? Actually, no, it should be the main component, so it should be the app component. What I'm talking about is function like something like this function. Component or create component, and this component will actually get the constructor, so it's going to be something like this, or maybe they put it like ctor, for example. Sometimes I saw in libraries. Here what we are going to have is for example inner HTML. And what else? We have to have like some kind of bindings as well, if we have any. So let's say bindings. And what we have to do here is something like this: const instance equals new constructor. And here, if we had like a dependency injection mechanism, what we could have done is using reflect metadata, get all the dependencies that the current, for example, component needs, get them from like our dependency injection container, and then just provide it to the individual web components. So this will probably be in the future episode. So here, what actually we need to do is somehow put this inner HTML. So these are the slots, usually what we use with slots, to the instance, and this is done by I think it was text content. So with the text content, we're going to just do like this, and now what we have to do is iterate all over the bindings. So let me just quickly say any here. Here, what we have to say string, or I'm just going to put any as well, and any. I don't know. I mean, currently I'm not sure what this should be. So I mean, bindings should be an object. So what we have to do is something like object.entities entries. And iterate all over the entries of this thing. So we're going to say key and value. So what we have to do here is basically attach these things to the instance. So say key equals value, something like this. And I think that we are going to be ready, right? It should be this. Actually, we need to return the instance. Let's see if it's going to work. Okay, let's see if it's going to work. So I'm going to remove this thing here, the router link. I'm going to comment it. And I'm actually going to use this function that I created. So I'm going to say component, create component. And I'm going to say what component I need. So one other thing that I'm going to achieve, like one other plus that I'm going to achieve with doing this, is actually that I won't have to do this thing that I'm doing here, the import router link component, just because I'm actually going to import it inside the router, and the router itself is going to use this router link. So this is something that we actually need to do before, just because we wanted for these web components to be defined before we were actually using them. But since we are now constructing them by ourselves, we actually don't need this. So we don't need to add it here anymore. So let's say import from, and where is the router link? I think it's the current, it's in the current, no, it's in the router link component. We need the router link component like this, and we're going to use this. And here we're going to say inner HTML, which is going to be test1. And bindings, what we have here is like an object. It has two, which is a string, and it also has, actually this is an attribute. But does it matter actually to it's an attribute? We can just do like this. Okay? It's not going to be an attribute anymore. Just because if it was an attribute, what we had to do is like have another loop that it's iterating over the attributes. And here inside the create component, to be able to say something like instance dot add attribute. Okay, you understand what I mean. I'm just quickly going to skip this part because I don't want to write other stuff. So I'm going to say that it's going to be a binding. Two is going to be to this, and what I else need is the router. So this is the tricky part here, because we're actually not creating the router by ourselves. So actually the reference will be created here on the bottom. So what it will be a good idea is to maybe extend this to a function instead of just being a real function that's returning immediately, and do the creation of the router here. Okay. So I'm going to comment this out as well. And I'm going to say const router equals create component, and now I'm going to reference the router itself as well. So I'm going to copy this, but here I'm going to say I want to get the router component and get the router component like this. I'm going to provide the router component. I'm not going to have any, so I'm going to say undefined. And do we have any bindings for the router? We have only the roots. There it is. Yep, and going to do something like roots equals this thing. Tap roots. And here, what we are going to do is just say we want to provide the router. And this is I think it's very nice, because it actually, if you're using Angular, you can kind of understand what Angular, like when the Angular compiler is compiling your templates, you can kind of understand what it's doing, because it's actually doing almost the same thing. Because whenever you're doing, like, you're using a template reference, let's say this router equals something, like, for example, ng router, even though there is not such thing, you're actually creating a constant or like a variable that is just referencing this thing that is going to get created, and whenever you're using it, you're just using it like a variable. So this is why, like, Angular is compiling the templates and it's converting them to JavaScript. So yeah, it's interesting. Okay, and here we have the other router link that I'm going to comment out and create it again like this, but this is going to be test2, and the path is going to be test2. And let's see if it's going to work. I'm just going to see if it's working. I'm not sure if it's actually going to, yeah, it's not working for now. Let's see why it's not working. This is interesting. So let's go to the router component. Let's see. No, it's the app component. Sorry, the app component. Let's see what's happening here. Maybe I did something wrong. Who knows? Okay, so we have push work. So we're returning the instance here. The instance is the router, actually. Actually, are we? I think that when are we actually calling the inside the component decorator the push work? Oh yeah, we're pushing it inside the constructor. That's good. So we have the update and we're calling the update here. Okay, so it's pushing the work. Okay. So my question now is, why isn't it showing?
Commit work. See,
I have a question. Do you do anything in your HTML that you're providing? Because we can show a lot of stuff. I'm not sure if you're using it at all.
Sorry?
Are you doing anything with the inner HTML that you provided?
Yes. The inner HTML, I'm just attaching it to the text content of the instance.
It's just
I missed that one. I missed that one.
Mm-hmm. So this is where this is actually, I think it was this one. Let me just quickly check. Text content, custom elements. Text content. I think it's text content. This is where the inner HTML, not text content, there it is. This is where the HTML for a certain element is just stored. So if we're using components, like web components, this is where the data for our slots will be used from. So, okay, so one other question, what I want to look at is if these things are actually created inside the DOM. So we have our navigation, here the router links. We have the slot actually, but the slot is missing. Maybe I'm mistaking something. Why isn't this working? Content, not context. Oh my gosh, okay. There it is. Okay, so now we actually see our two links, and let me see when actually we're rendering this. I'm wondering if it's going to be inside the first commit phase here. No, it's inside the second one again. Anyways, I mean, it's kind of a progress. We're going to see why it's not inside the first. Oh, I know why it's not inside the first, because here, if we go inside our index, we're going to see that we are actually importing the app component itself here. And this means that it's not going to be working the way we're expecting it. So in order to be able to do this, we'll have to create our own, like a bootstrap function that actually creates the component. So let's do this. So let's say function bootstrap. And here inside the function, what we're going to say is constructor. Pretty much it's going to be the same. I'm actually going to export the other one into a different file, and I'm going to be reusing it across my application. So let's say lib and create component. Export, and then here I'm just going to, come on, import it.
Why isn't it working? Come on.
And why is it with a capital letter? I mean, it's just a function, so it should be with a small letter. I'm not sure why I created it like this. Come on, TypeScript, can you find it or no?
I think for some reason it's struggling.
Well, it's always struggling when it's online. Okay, lib create component. Oops. Okay, and here we need the create component. Okay, now we're going to use it here as well. We're going to import it from the lib create component, and I'm going to say this is going to be any, and here we're going to say constructor instance equals this thing. Let me just say something like these parts are not necessary. So here we're actually going to say something like this. So we don't need to write an extra if condition. And let's see what's going to happen. No, we are still not finished. Actually, we need to remove this, and we're going to say div with ID something like app. And here inside the bootstrap function, what we're going to do is say document.getElementById app. This is going to be the app or container. And inside the container, what we want to do is say append child, and we're going to include the instance. And this actually should allow us to have a single iteration maybe of our work loop and maybe see everything. Who knows? Maybe not. I don't see anything. Actually, let's see.
Should you call the bootstrap function somewhere?
Yeah.
Oh yeah. Exactly. Thank you, Harry. And here what I'm going to actually provide is the app component. So this bootstrap function, I'm actually going to put it here as well inside our lib. Bootstrap.js exported, use the create.
Come on, why? Oh, TypeScript, why are you like this sometimes?
No, I think it's not from the TypeScript, or maybe it's from Visual Studio Code.
Yeah.
It's
It's really frustrating when you expect stuff like this to work and they still just like, nope.
It's not working here as well, so I'm just going to say bootstrap. How much time do we have actually? What is the time?
No more than 15 minutes. We have like 15, 20 minutes left.
Okay, perfect. Bootstrap, and here we're going to provide the app component. Oops, it's not exported, maybe. Let's see. Yep. The app, wait a second. App component. Why is it called root? Oops. They add certain functionality that it doesn't help you.
Yeah,
They don't understand it.
Sorry?
They don't understand that this functionality, whenever you click like 2 times like the copy, I really don't want to copy the whole line. I'm not sure. I mean, I never used it, but maybe it's the problem is in me. I don't know.
Yeah, I hate issues like that.
Okay, so this should be actually rendering something. So here we're, come on, what's okay? Let me just go to the default route. Okay, it's still not being called. Why is this? Oh, we ended up in the constructor. Okay, I think now it's working. We're committing. Again, it's on the second one. Why? Why is it on the second one? I don't understand why. So here we're creating the root, and whenever we're creating it, that's interesting. So we're creating it, we're getting this thing. So whenever we're creating it, we're running the, maybe it's inside our component decorator, something like the problem. When are we actually calling the update? But we're calling it inside the constructor, so this is okay, right?
Looks good.
What if we call it after the current stack has finished? It probably is going to change things, maybe, we'll see. So here we're committing the work. Again, we're not seeing what we want to see. These things are getting created on the next iteration for some reason. This is the directive. This is why, the outlet directive. But no, these are the router links. They should appear in the first iteration, right? Why is it not working? Any ideas, guys?
Oh, it's certainly happening because the other components don't use the create component function.
No, it doesn't matter. What I'm struggling with is whenever I refresh, what I want is for the first commit, whenever we construct the components here, to actually see the oh wait, I think I know why it's happening. To actually see the router links here, to see test 1 and test 2.
Yeah. And in the initial commit, like for them to be pushed immediately.
But here we're actually doing the work. As you see, we are actually coming inside the create component. This means that the create component will be called, but here we end up in the commit work. I think commit work should be we're kind of not waiting for them to get pushed into the current stack though. So that's the into the current process. That's the problem. So I'm trying to see where we're doing it wrong, but here whenever we're creating the component, we are calling the constructor. We're coming here. We're attaching whatever we want to attach. So yeah, this is not good. This is this. Yeah, maybe I should have. Let me just put a breakpoint. Now we commit the work. So this commit work should be asynchronous. But okay, let's remove these parts from the constructor, from the component then. So let's remove this to see how it's different than what we had. So let's refresh. We come here. Now we call the update. This is for the root. Okay, we don't care about this. So we are creating here the component. We end up in the decorator. No, we actually, yeah, we end up in the decorator. So now the update is being called. The update actually is pushing the work asynchronously. So this is the problem. So we should remove this thing. This is the problem. Because now we're actually going to commit. Yeah, okay. Let's remove this part then. Something like this, maybe. Who knows? Wait a second. This update should not be here. It should be inside here. right?
Yeah, that's where it should be.
Okay. And let's see. Okay, we're coming here, entering. Okay, we're pushing the work now. And now we're constructing the router links. Hopefully, we're not going to end up. Yeah, we're pushing the work now.
Before actually
Okay.
commit.
And now it's committing, and we don't see them again, which is strange, but they should be here, actually. They should be here in the navigation. There they are. The problem is, yeah, currently we don't have the request animation frame being called, and that's why we're not seeing them. But as you see, they're here. We just haven't built them. So that's the problem here. So probably a good idea is maybe to have the commit to be done inside the request animation frame.
Yeah, so that they can be
But,
shown.
but I see another problem with this, and I think that this is what actually React they're trying to achieve by using. Actually, they're using this message channel. So I think that the best idea is to kind of end the example here, because we have only 10 minutes. So let's end this episode at this point. But let's see actually that they're going to be rendered. There they are. Okay, it's currently not working because we haven't modified our application to work correctly. So what I wanted to say is, if we put the commit work inside our work loop, inside the request animation frame, we're going to miss if inside the request animation frame we're doing certain changes on our, for example, bindings on our components, or I don't know, if you're doing certain animation. So what we want to do is to not push the work inside the current animation frame, but to catch the other one that is going to be after that, and then to commit the work or something like this. Even though, because currently probably we're not doing any stuff like weird, if we do the request animation frame and use a callback and put this, I think it's going to work. But I'm not sure if this is stable enough for in our case. So let's just see if it's going to show. So what I want is to pause inside the commit work. There's the commit work. Okay, we're committing the work. And okay, where should I, like, which components? I think the test one component, the constructor is going to get called a little bit later. Okay, I guess not. Anyways, you saw that it's on one piece. It's not like on multiple pieces while we're debugging. So this fixed the problem. Anyways, we have a few minutes left. So what I want to quickly show you is what the React people were doing. So of course, they're using a min heap. This is the documentation for a min heap. Usually they have the scheduler that is prioritizing work. This means that more important work is on top of the heap, and they're getting this work and they're doing it inside this work loop of theirs. But if you go inside the scheduler, you're going to see that they're actually not using request idle callback. Instead, they're using a very interesting technique, which is with this, I'm not sure if it's here somewhere, message. It's split into multiple files. Yeah, this is the message channel. So they're using a message channel. And what they're doing is that they're saying, okay, I'm creating this message channel, and message channel is pretty much a message bus. You communicate with two parts by sending messages. And here what they're doing is saying that on message, I'm going to be performing work. And by doing this, they're not scheduling a micro task or a macro task, they're scheduling an event. And the difference between the callbacks, like when you're using set timeouts or like request idle callback or request animation frame, is that the callbacks are always run on the end of the event loop. And events, on the other hand, for example, the messages, because this is an event, they're run in the beginning of the event loop. So this is why they're using this, at least I think so. And yeah, we're going to play around more with it. Probably, as I mentioned, we can actually use the scheduler. You can download it from npm by doing npm install scheduler, but it's still work in progress. And you actually see that the APIs, all the functions that you're going to be using, are with, I think, unstable in front if you start using them. So just so you know that it's not ready for to be in use. But what I have in mind whenever we were writing this thing here is that what if we get the lit HTML function that is actually parsing this stuff. And I think that a while ago we actually were looking at it, right?
Yeah, I think
When we were talking about the directives, I think we were actually talking about. Let's see where it is. So actually, this is what we need: the default template processor. So this is what we were looking at when we were talking about how the binding works, how we bind events and stuff like that, right?
Yep.
So what if we create our own template processor? And this template processor, what it's going to be looking is for custom elements. And we can easily recognize custom elements because they have a dash inside their name. So what we can do is create a custom, for example, processor and say, okay, if in the name you have a dash, I want to use the custom elements get constructor or something and instantiate the component myself. Why not? This maybe will work. I'm not sure. We can test it out. Where we can see where what we can do. But this is another idea that we might do in the future episodes. But for now, I think that in the next episode, what we have to do is just make our application work. So just to present our component here. And what actually it's not why is it not working is because I think that inside the work loop we have one task that is left. Let's see. Oops. No, it's not this one. Well, I don't know. We have to debug it. We have to see why it's not rendering our active components inside the router. But anyways, I think that we kind of made a little bit progress on having asynchronous rendering. And I hope that you understand what asynchronous rendering is and why it's very useful. And why the React team is very focused on creating such a thing, just because their framework is doing a little bit more work than any other framework that exists, just because of this diffing and construction of the whole tree and diffing and stuff like that. Okay, so I have a bunch of links. Actually, lit element is a library that is built on top of lit HTML. It allows you to have asynchronous rendering, but for me it's very ugly because it looks like this. As you see, it's not being pushed at the moment, like at one particular moment to push all the changes, but it's really asynchronously. And they're using set timeouts, which is something that I'm not really I'm not very interested in. But yeah, this is an article that you can read. Pretty much, it explains why you need the asynchronous rendering, that you want everything to be smooth without jank and stuff like that. And you can see the lit HTML, the lit element, how they do it. But I'm not very interested in this. I mean, it's pretty simple. It's pretty simple to create it, and I don't like how it's rendering the stuff. This is the synchronous rendering. As you see, it's a little bit slower. This is the asynchronous. It's not blocking the browser at all, but it's not displaying the elements very nicely. I mean, I don't like this.
Yeah, it really depends on what you're trying to show, but having your main structure of your application being shown like this one, it's not that good.
Yeah, I mean, what we're actually doing is creating a buffer. We're getting all the changes that we have for a certain time inside this buffer, and then we're committing the buffer inside the template. So I think that it's much better, but I don't like it like this.
Yeah,
Plus, I think that if you're doing it like this, I think that you're actually doing more work to the browser. I mean, it's not rendering on one single iteration, it's rendering on multiple iterations. So, but I don't know. I mean,
it really depends on what exactly you're rendering, because in some cases you might want to just render something in the split second, the split millisecond you want to show it, but it's really niche. Like, I think our approach of rendering the whole thing in one run is really better.
Do you know what the problem about this is? At least from my perspective, I think that if we have, for example, A here and we also have A here, they're going to have different values at a certain moment.
Yeah.
And this is something that I really don't want to have, because, for example, can you imagine if this is something important? If you have building, like, for example, our application that we're working on, the portal.
This is an option.
It's not a good idea. So
yeah,
this is why frameworks like React and Angular and stuff like that exist, you know.
What I was implying is that in some cases this might not be that much of an issue, but in most cases having it properly asynchronously rendered is the better solution.
Yeah, I agree. So these are the links from the previous time that I wanted to show you. This is the main thread scheduling. These are just ideas of what is going to happen probably in the future. And yeah, if you're interested in, I will probably put them inside on the bottom of today's video. And you can also check the React scheduler. You can play around with it. You can check those issues with the async rendering. I really like that the React team is explaining things very well inside the issues, and they're kind of trying to give more information to the users that are kind of using React or want to contribute to React. So this is very helpful. And yeah, this is all from me. Guys, do you have anything to say?
Like, I don't know, but in terms of picks, maybe something. Harry, do you have anything to add? Because I noticed one small library actually really caught my eye. It's really a simple thing. Let me just send the demo. I lost it. God damn it! Just a moment. And I forgot how it's called. Amazing. So it was really simple, a really simple library. It's just like one file, but the idea was that while you're moving your mouse, it can detect which element you're most likely going to click, and when you're moving towards an element, it gives you the ability to predictively modify your DOM for when you're going to do something. For instance, if the mouse is moving closer to the save button, you can just expand it or do some sort of animation. And it got me thinking on how exactly you can use it to enhance the user's interaction and experience.
Sounds great.
If you find it, just send it then.
Yeah, just give me a moment.
In the meantime, Iliya, I send you a link, which is a link to the open source awards, the JavaScript category, and pretty much this is like 9 or 10 libraries that are like very popular right now, or just cool. So if anyone is interested, you can share this link. I sent it to you in StreamYard in the private message. Yeah, you saw it. So right now, if you scroll down, you see this library that I mentioned last time, which is called List. You see some interesting, like, working with time libraries. There's, if you scroll a little bit more down, there's like it's somewhere around here, but it's like analog at moment.js, but just into kilobytes. So there are a lot of interesting stuff here. And if you have,
this is cool. This is interesting, definitely. I think that everybody interested in JavaScript should check this out.
Definitely. Also, I sent the link. I found it. It's called Premonish.
You just copy and paste it. By the way, Aleksander, you can share your screen as well.
You can show the debug view so that you can see how exactly it's. No. It has a show debug view link in top.
Where? Okay.
Yeah, and we can see how exactly it's trying to find which is the element you're going to select.
That's really cool.
And it's for me, it was interesting that just starting to think about how exactly you can implement this. I think it's interesting for me at least.
I wonder why it's like it has like some kind of fixed length that is trying to figure out if there is like an element
Yeah.
near the thing.
Every element I think has some sort of radius. It's creating some sort of radius, and it's using that fixed length to look around itself.
That's cool. That's cool. Probably this is very useful for like building games and stuff like that. Maybe.
Yeah,
I'm
yeah,
not
yeah.
sure. But yeah, this is cool. This is cool. I like it. Okay, so I don't know. For I guess my last pick is just this library. It's everybody in the stream knows. It pretty much is it's not actually a library, it's a language of its own, and it allows you to like have a reactive to write reactive front end like applications, and it's kind of strange. I'm not sure how to pronounce it. Does anyone know how?
It sounds like something Scandinavian to me.
Yeah.
I don't know. But yeah, you can like what you do is like write these kind of scripts, and then you just I don't know. It's very strange like the way you do it. I kind of am very like interested because look at it, it's just working, and you've just written like a few lines of code. Usually, like even if you construct web components and stuff, you write more code than this. But after all, it's like a component, and here it's like some script files, and I really kind of don't like that it doesn't have the component architecture in it. But it's a really interesting framework. I would definitely look into how it's created and how it's working because it's just interesting. I don't know. It looks very interesting.
It looks cool.
A few simple lines of code and you have this thing.
The counter application, which is the default application for many devils.
Yeah. It's interesting if they have this like a work loop or how are they rendering stuff. It's very interesting.
I think that if you scroll up, I something caught my eye. The stores like life cycles.
Life cycles. Where is it?
No. You're in the life cycle actually. It's on mount, on destroy, before update, and stuff like that.
Okay, so you actually you do have components. I guess the components are the individual script tags. Something like this, probably. I don't know. It looks very interesting. Well, it's worth definitely checking out. So we'll check it out at a certain point. I'm just.
That's cool.
Okay. Anyways, I think we're done for today, and the next time we'll just continue with fixing our application, and hopefully we can achieve what we're trying to achieve. Okay, guys, if this is all, let's end up the stream, and we're going to see each other hopefully next Saturday.
Yep.
See you.
Bye.
Bye, everyone. Have a nice weekend.